Not all deserts are without water. In tropical coastal deserts, water appears in the form of morning mist, but it disappears quickly when the sun rises. So the clever locals set up such a museum net. Let the tiny water droplets condense on the net, retain the morning mist as drinking water, or turbidity-free irrigation water, but the efficiency is too low, and the conversion rate is only about 10% in the best case. When I was riding the plasma wing before, I accidentally discovered a problem. The dry ice produced mist, which was sucked in by Li Jifang. Some of it passed directly, and some condensed into small water droplets on the negative electrode. Does that mean that electricity can increase conversion efficiency? Let's just design a simple model and do a little experiment. In addition to this hollow tube used for expelling mist and installing the positive electrode, this one is for hanging the negative electrode. The fog net is also 3D printed, which is simple and convenient. Since the positive and negative electrodes are relatively long, I opted for segmented printing. Using a special PLA adhesive, I can bond the printed parts together, allowing them to withstand significant stress. I installed the metal mesh horizontally in the middle to serve as the positive electrode. Pulling out a few strands, to expose the tips, I prepared an acrylic board, cut it to the right size, and glued it together to make a simple box for collecting water. Place the fog net and the previously assembled positive electrode into the water, along with the ultrasonic nebulizer. It's used to simulate morning fog. And after connecting everything, the drainage is normal, but it's not powered on yet. Let's see if this device can turn the mist directly into water droplets. Oh no, this clearly isn't working. After waiting for a long time, there's not a single drop of water on top. Look, even when I touch it with my finger, it feels like a sticky gel. I should try using the old transformer I made before. If I turn it all the way up, the voltage can reach around 8,000 volts. Then I paired it with a voltage multiplier to output 35,000 volts of direct current and connected the negative electrode properly. And Zheng Bao is anxious to see the effect. Oh, did you see that? The state of the mist has changed immediately. It now has direction. All the droplets have been attracted to the metal mesh of the device. Look, it hasn't been long, and water droplets are already forming. It's happening so fast. It's not even been a minute, and the net is already covered with droplets. The mist is condensing faster and faster now, and it's already dripping into the water collection box below. After almost 5 minutes, there are little puddles forming below. I didn't expect this device to be so useful. It's really amazing. Now let's collect all the water from the net and set it aside for a moment. Next, I'll prepare a battery scale to pour all the water in and see how much we've collected in 5 minutes. Look at that. It's actually 40 grams. The entire device is a bit bulky and needs some improvements. This time, we're using an insertable column design, with the power assembly column on the right and the anchor column on the left. Of course, these two parts are still being prepared with 3D printing for the small transformer. The diodes and capacitors are soldered in several steps, and the input and output voltages are about 20,000 volts. If you don't know how, you can also buy a ready-made high-voltage module. Install it in the reserve position, and then mix epoxy grease to fill it in for simple packaging. The 12G battery is glued to the flying surface, and this is how it looks after installation. It is much lighter than before, and easier to install. Just plug it into the ground. I bought a large fish tank to simulate the desert environment, and also bought a cactus to make it more realistic. Now pave the path in the tank with coarse sand, dig a hole in the desert plant, insert the power pole near the tank, insert the rivet pole at the other end, connect the two together with a stick in the middle, put the grain metal mesh on it, connect it to the negative terminal, wind the ultrafine wire as the high voltage positive electrode, and the high efficiency grain device is completed. Isn't it simple? The positive electrode above carries 20,000 volts of high voltage electricity. When the water droplets of the species come into contact with the wire, the battery will be stolen. This gives them a positive charge, and the metal mesh, just a few centimeters below, can catch them effectively. Now I'm starting to create mist. First let the mist envelop the entire desert. Set up and it's full now, so we can open the shop. Oh, I see you didn't react quickly. The dragon mist quickly dispersed, and water droplets began to condense on the metal net. It is obvious that more and more of them can no longer hold on, and are dripping directly into the desert, especially below. After a long drought, the desert has finally welcomed some much-needed moisture. You can see that the sand under the condenser is already soaked, forming a very clear irrigation line that can be used to grow plants. There's also a water collection box underneath, which has been running for 5 minutes. The collected water is about 47 milliliters, with lower energy consumption and better results. If we scale this up, could we really turn deserts into oases?